Science with Folly.
Kia ora, welcome to Science with Folly. Today we're going to be learning about percentage compositions, yields, and empirical formula. Ready to go? Firstly, just a quick recap of moles mass and molar mass. Remember, we use this formula N equals mass divided by the molar mass to calculate the number of moles. So for example, I want you to calculate the number of moles in 200 grams of copper sulfate. So firstly, we've got to calculate the molar mass of copper sulfate. And as you can see, we've got one copper there, which is 63.5, one sulfur, which is 32.1, and 4 oxygens, which is 4 times 16, to give us a total molar mass of 159.6 grams per mole. From there, calculating the number of moles is pretty easy. We just use the formula N equals mass divided by molar mass. And the mass up here is 200 grams. The molar mass, 159.6. And what does that equal? It equals 1.25 moles to 3 sig figs. So now let's look at percentage composition. This describes the percentage mass of each element in a certain compound. So, for example, let's use copper sulfate again. So we know the molar mass of copper sulfate is 159.6 grams per mole. Therefore, let's start off with copper. The percentage of copper is going to equal the molar mass of copper, which is 63.5, divided by 159.6 times 100 to give us a percentage, and that gives us 39.8%.
Let's look at the percentage of sulfur. The molar mass of sulfur is 32.1, divide that by 159.6 times by 100, and that gives us 20.1%. And finally, the percentage of oxygen equals 4 times 16, because the molar mass of oxygen is 16, so that's 4 times 16 divided by 159.6 times 100, and that gives us 40.1%.
And as you can see, all those percentages add up to 100%. Pretty good, eh? So now let's look at yields. This describes the theoretical amount of something that is consumed or produced in a chemical reaction. So let's do an example question. If we've got sodium plus water, it gives us sodium hydroxide plus hydrogen gas. It's a pretty cool reaction. You might have seen it in one of my videos. So if we can calculate the mass of sodium hydroxide that can be produced from 10 grams of sodium metal. And we can do that first by calculating the mass of sodium hydroxide and sodium metal.
The molar mass of sodium hydroxide, NaOH, equals 23.0 for sodium, plus 16.0 for oxygen, plus 1.0 for hydrogen, and that gives us 40 grams per mole. The molar mass of sodium metal is simply 23.0 grams per mole.
Then we can calculate the number of moles of sodium. The number of moles of sodium is going to equal mass divided by the molar mass. Our mass is 10 grams divided by 23.0, and that gives us 0.435 mole of sodium metal. Now, from that we can figure out the number of moles of sodium hydroxide. If we look at our equation, it says 2 moles of sodium gives us 2 moles of sodium hydroxide. So the ratio is 2 to 2, or simplified 1 to 1, which means if I've got this many moles of sodium, I'm going to have that many of sodium hydroxide. 0.435 times 1. If we had double the moles here, I'd times it by 2. Or if we had half, I'd times it by half. And obviously that's just 0.435 moles. Then finally, we can rearrange our equation, which is mass equals the number of moles times the molar mass, and this is for sodium hydroxide, is 0.435 times our molar mass, which is 40.0, and that gives us 17.4 grams. So I can say that from 10 grams of sodium reacting with water, I can get about 17.4 grams of sodium hydroxide. And now, lastly, we're going to look at how to calculate empirical and molecular formula from the percentage composition. So let's say I've got a compound which is 39.3% carbon, 8.2% hydrogen, and 52.5% oxygen. How can I calculate the empirical formula? Well, to start off with, to make it easy for myself, I'm going to draw a table with 3 columns. First column, I'm going to put carbon, hydrogen, and oxygen. This row is going to be mass. And I'm going to pretend each of those percentages is just a mass in grams. So I've got 39.3 grams of carbon, 8.2 grams of hydrogen, and 52.5 grams of oxygen. From there, I can calculate the number of moles, because remember, number of moles equals mass divided by the molar mass. So I just go 39.3 divided by 12 for carbon, 8.2 divided by 1 for hydrogen, and 52.5 divided by 16 for oxygen. And those answers are 3.28, 8.2 obviously, and 3.28 there for oxygen. That gives me the number of moles. Now I divide them by the smallest number here. And as you can see, 3.28 and 3.28 are both the smallest. And so 3.28 divided by 3.28 is 1. 3.28 divided by 3.28 is 1. And 8.2 divided by 3.28 is 2.5. When you look at this, you can see this would tell me that I've got 1 carbon, 2.5 hydrogens, and 1 oxygen. But you can't actually have half an atom. So what we have to do, we have to times it by 2 in this case. Sometimes if you end up with 0.3 or 0.6, you'd have to triple it. Or if you end up with 3 whole numbers, then you don't have to do anything. Timesing it by 2 gives me 252. So my empirical formula equals C2H5O2. Piece of cake. So now we're going to calculate the molecular formula. So if you were told that the molar mass of the compound we just calculated is 183 grams per mole, how are we going to figure out the molecular formula? Well, first of all, we calculate the molar mass of C2H5O2.
And that's going to equal 2 times 12 plus 5 times 1 plus 2 times 16. And that gives us
61 grams per mole. Clearly, those two are different. So we go 183 divided by 61. What does that equal? 3. Therefore, pretty easy. We just multiply this whole formula by 3. So our molecular formula is going to be C6H15O6. Piece of cake. Well, I hope you learned something about this. And the key thing with all this stuff is you've got to practice your calculations. If you don't practice, you'll find it hard. It's just like riding a bike or playing piano. Whatever you do, practice, practice, practice. Ka kite anō. Have a good day.
Science with Folly. Science with Folly.